Welcome back, everyone. Now listen, if you are joining me today, you're most likely staring down the barrel of a Cambridge computer science exam. And whether you're tackling syllabus 0417, 0478, 2210, or 9618, you have almost certainly faced this incredibly frustrating situation. Actually, scratch that. It's not just frustrating, it's downright demoralizing. You study for weeks, right? You highlight your notes, you memorize every single definition, you walk out of the exam hall feeling like an absolute champion, and then the results come back, and you've lost marks, sometimes a completely shocking amount of marks. You're sitting there thinking, but I knew the facts. Well, today, we're not just going to review basic computer science facts. You already have textbooks for that. Instead, we are going to get right inside the Cambridge examiner's head. We are going to act like psychologists for this explainer to figure out exactly what they are looking for when they read your answers. And more importantly, we're going to learn how to give it to them, flawlessly, every single time.
So, the absolute crucial point we need to address is this question right here. Why do students who know the facts still lose exam marks? To really understand this, let's look at two typical student archetypes that examiners see thousands of times every year. First up, we have Alex. Now, Alex is a walking textbook. When asked a question about binary and denary systems, Alex will completely overload the paper with raw facts. Alex will write down that binary is base 2, denary is base 10, computers use switches that are on and off, it's all ones and zeros, it's a massive data dump. But here's the problem. There is absolutely zero analysis of the actual question being asked. It's just noise to the examiner. Then, on the other end of the spectrum, we have Sam. Sam is the rusher. Sam actually knows the material really well, but panics against the ticking clock. Sam completely ignores the specific commands word in the question, like evaluate or explain, and just writes a super generic, rushed summary. Both Alex and Sam are falling headfirst into the exact same trap, the rote memory trap. Relying solely on your memory of facts, without demonstrating an understanding of the core mechanism of how those facts apply to the specific question in front of you, is a guaranteed way to bleed marks. It happens every single year.
Okay, let's dive into this. Here is our roadmap for today's journey. First, we'll completely unpack the exam mark trap. Second, we'll explore the 3 layers of mastery. Third, we're going to build the answering blueprint. Fourth, we'll see exactly why context is everything. And finally, we'll wrap up with the final self-check to make sure your answers are bulletproof.
Let's start with section 1, the exam mark trap. A simple definition is never, ever enough to secure top marks. I need you to really hear that. Let's take binary and denary systems as an example. A strong, high-level understanding in computer science doesn't start with a vocabulary list. It always starts with a problem. What actual problem does binary solve for a computer? You see, examiners aren't testing if you have a dictionary stored in your head. They are testing if you understand the practical consequences of a concept for a user, a system, or an entire organization. When you just drop a definition onto the page, you're only telling the examiner you've memorized a sentence. You aren't proving that you understand it. Look closely at the difference between what you are probably doing right now and what you actually should be doing. It comes down to description versus explanation. A description simply tells the examiner what the device or process is. It's safe, sure, but it is incredibly shallow. An explanation, however, tells them exactly how it works and why it matters. And guess what? Examiners almost always expect both. If you just describe, you immediately hit a ceiling on your marks. But if you jump straight into explaining without identifying the core concept first, your answer reads as confused and unstructured. You have to link the device to the process and then carefully link the process to the outcome. That is how you break out of the trap.
Moving right along to section 2, 3 layers of mastery.
To permanently avoid that rote memory trap we just talked about, we use a highly effective strategy called concept compression. The source material points out a truly fascinating psychological reality about studying. It turns out students falsely believe they know a topic when they are sitting comfortably at their desks at home, casually reading through their notes. It feels easy, right? But true mastery requires you to move your brain through 3 distinct layers. If you can't compress your knowledge into these 3 layers, the intense pressure of the exam hall will completely unravel your memory. So, layer 1 is everyday language. Can you explain the concept to your grandparents? Can you simply say, computers only understand electrical signals being on or off, so we use a system of 2 numbers to represent absolutely everything? If you can do that, great. Layer 2 is technical vocabulary. This is where you swap those everyday words for subject-specific terms. Now, instead of 2 numbers, you are talking about base 2, base 10, logic gates, and data representation. But listen to me, here's where 90% of students stop. You absolutely cannot stop at layer 2, because layer 3 is the exam explanation. This is the ultimate test. This means shaping that technical knowledge into a perfectly structured response that actually scores marks under immense time pressure, directly answering the specific prompt in front of you.
Before we continue, subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's get into Section 3, the answering blueprint.
We've talked extensively about the flaw, so now let's talk about the formula. The absolute secret to high-level computer science reasoning is spotting contrasts. When you read an exam question, your brain should instantly start looking for the boundary between similar concepts. Are they asking you to compare memory versus storage? Are you looking at a compiler versus an interpreter? Or maybe validation versus verification? Once you clearly understand these boundaries, you can apply our blueprint. You need to treat your exam answer exactly like a well-written piece of code. It needs to execute logically from step A to step B without throwing any bugs or errors. Here is your incredibly powerful 4-step answering blueprint. Step 1. Identify demand. Look closely at the command word. Is the examiner asking you to state, describe, explain, or evaluate? Each word requires a totally different approach. Step 2. Classify the concept. What exact part of the Cambridge syllabus are we dealing with here? Step 3. Explain the sequence. This is vital for process-based topics. You must order your steps logically without jumping forwards and backwards. Don't start at step 3, go back to step 1, and then jump to step 4. Step 4. Connect to context. Does the answer need an advantage, a disadvantage, or a specific design choice applied to a real-world scenario? This blueprint, which is often called the Peel framework for point, evidence, explanation, link, is your ultimate safety net in the exam hall.
I want you to notice this stark contrast between these two responses on screen. We have a quick 30-second challenge for you right now. Look on the left, we have Alex's response. It's a massive wall of facts about binary, just fact after fact. Now, on the right, we have Sam's revised, perfect 4-step Peel paragraph. Scan them quickly. Can you see exactly why Alex's paper is absolutely covered in red marks? Alex just threw basic definitions at the page, hoping something would stick. Now look over at Sam's green check marks. Sam identified the demand of the question, clearly named the concept, explained the logical sequence of how data is actually processed, and then beautifully linked it back to why it matters to the user. Every single time you shift from dropping a raw fact to providing a sequenced explanation, you add a definitive mark to your final score. It is really that simple.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's jump straight into Section 4. Context is everything. The core mantra for this interactive workshop segment is that context acts as a main character in your answer. Let me say that again. Context is a main character. Generic responses rarely, if ever, gain full marks. If a question is specifically set in a school, a busy retail environment, or a highly secure banking system, your answer must stay locked inside that context. Let's test this right now with Challenge 1, the data scan. You have a 60-second visual countdown to mentally scan this table. Look at how a very generic concept like data representation completely transforms based on the real-world application. In a school management system, binary might just be representing student attendance records through very simple logic states, present or absent. But if the question is about a banking system, we are suddenly talking about high-level encryption protocols and secure online activity where data integrity is absolutely paramount to stop financial theft. If you accidentally give the simple school answer to the complex banking question, you lose marks, even if your underlying computer science theory is technically correct. The real-world transfer is what converts your raw memory into actual scorable usefulness.
Let's keep the momentum going with Challenge 2, Find the Flaw. I'm going to rapid-fire the absolute most common mistakes that completely ruin exam paragraphs. As I read these, I want you to be honest with yourself. Which of these are you guilty of? First, vague wording, using words like thing or stuff. Second, confusion between similar terms, like mixing up the internet and the World Wide Web. They are not the same thing. Third, missing process steps. This happens when you jump from step 1 straight to step 4 because you falsely assume the examiner just knows steps 2 and 3. You have to write it out. Fourth, failure to answer in context, which we just covered. And finally, the biggest trap of all,
stating an unjustified advantage. This means saying a system is faster or cheaper without actually explaining why the underlying computational mechanism makes it faster or cheaper. Faster is not a magic word that gets you a mark. Error-aware notes, meaning notes where you specifically write down the mistakes you shouldn't make, are far more useful than notes that just contain correct facts.
And now it's time for Challenge 3, Speed Writing. Imagine a 30-second visual timer on the screen right now counting down. Your task in an actual exam is to write one perfect paragraph explaining a core mechanism, like exactly how an interpreter translates code, without relying on memorized robotic wording. You need utter clarity of sequence. You must explain the mechanism first, step by step, completely logically, and then state the consequence. Don't jump backwards. Paraphrase your knowledge accurately, structure it clearly using our blueprint, and hit the context dead on. That is exactly how you survive and thrive in the exam hall when the pressure is at its absolute highest.
Finally, let's bring it all together in Section 5, the final self-check. So, let's review. We've decoded the command words, we've actively applied the PL framework, and we have anchored our answers deep in context. So, how do you know your answer is actually ready to submit before the time runs out? Before you move on to the next question, you must be able to answer these 4 specific prompts aloud in your head based only on what you have physically written down on the page. 1. What is it? Have you explicitly named the core concept? 2. How does it work? Have you explained the sequence logically, step by step? 3. Where is it used? Have you directly addressed the context of the scenario provided in the prompt? And 4. Why is it better or worse? Have you thoroughly justified your evaluation or design choice without just using hollow words like faster? If you can mentally check off all 4 of these prompts, your answer is ready. It's solid. If not, you need to go back immediately and add the missing link before moving on.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
Before we officially wrap up, I want to leave you with one final provocative thought to test everything you've learned today. Look at the challenge on the screen. Write your own extended response question on binary and denary systems, but more importantly, outline exactly what a high-level, maximum mark answer would include based on our PL blueprint. Put yourself right in the examiner's chair. What specific sequence, what context, and what contrasts would you demand to see from a student? Try this exercise tonight. It will completely change how you view your entire syllabus. Keep studying smart, keep analyzing those command words, and I will see you in the next explainer.